Hey everyone, welcome back to Java Programming. In this video, I'm going to talk about inheritance trees and how we can use them to kind of drive out what our subclasses might be and where the different methods or instance variables belong. So here, if we start with kind of a sort of a messy tree, if you will, we have an animal class with a bunch of instance variables and 4 methods: make, noise, eat, sleep, and roam. So all things that animals do. And then we've got a whole bunch of subclasses underneath them: lion, hippo, tiger, dog, cat, wolf. You could think of many, many more. So as we're thinking about how we might break things down, we probably need to override some methods, right? So not everything can really live up in the animal class. So if you think about make noise, for example, all of these different animals are going to make different noises. And so the make noise method probably really belongs down, overridden in each of the subclasses. And so what we think about, and eat as well, at least in this example. So down here, we've now moved those methods, or overridden, not really moved, overridden those methods in each of the subclasses. So at that point, that's kind of the bare minimum that we need to think about. And if we head back over to our example with our vehicle being the superclass, here we had a car that was a subclass, and then we overrode the display method, or the start method, right? So that one was overridden. And same thing with the airplane. And then we can also think about what additional instance variables we might have. So in this case, we had number of engines, and we had number of cylinders, and then get and set methods for each of those. So that was additional. That wasn't just what we were overriding, but those were additional instance variables and additional methods. The only thing we overrode there was the start. And so it's a little bit harder to have that kind of tree example here, but the subclass notation here indicates that there would be an arrow coming down from vehicle to car, truck, airplane, and bus. So that's pretty much all you need to start creating your own inheritance trees, is understanding the notation and then thinking about that process of determining, okay, which of the methods would need to be overridden, which instance variables would live down in the various classes. And we can take that a little bit further here. So ultimately our goal here is to avoid duplicate code, right? And so if we think about a method like roam, different categories of animals probably move about the world in a similar way. So if we look at this next version of our inheritance diagram, you can see that we've added a couple new classes. So we can have superclasses that are also subclasses, right? So canine is a superclass of dog and wolf, but it's a subclass of animal. So here you would have dog extends canine, canine extends animal. And it's in the canine and the feline classes then that we have the roam method, because dogs and wolves, will imagine in this scenario, move about the world in a similar way. And same thing with our lion, tiger, and cat. Feline would hold that roam method. So that adding of 2 new classes here allows us not to have to write that roam method or override the roam method in each of those classes. We can put kind of an in-between class to handle that stuff, an intermediary class. And then that brings us to the is-a-has-a test. So I think with animals, it's pretty straightforward what the classes might be, and then what the instance variables might be, and what the methods might be. But sometimes you're in a situation in a system where you're just not sure. And so there's a great way to be able to test this out, and it's using the is-a-has-a test. So you can think about, for example, a relationship between a fireplace and firewood. Fireplace has firewood. So has indicates an attribute. So if you were imagining a fireplace class, so if we had a class called fireplace, and then we had instance variables. You might imagine a Boolean for has firewood, or maybe just firewood. Okay. So in that particular system, firewood is an attribute or a field or an instance variable on fireplace. Same thing with the refrigerator and last night's pizza. So they're probably not separate classes in this case, but instead refrigerator might have an indicator on it whether or not last night's pizza is in there. Dog and a poodle, well, that has that inheritance relationship again. So can we say a dog has a poodle or a poodle has a dog? It's easier to say a poodle is a dog. So poodle then is a subclass of dog. Dog is a poodle. That's not necessarily always true, right? So dog is the more generic form. So heading back to our example here, so car is a vehicle, which indicates that subclass relationship. Same thing with the rest of these. A truck is a vehicle, an airplane is a vehicle. An airplane, though, has a number of engines, so that has a relationship indicates an instance variable. Same thing here, car has a number of cylinders. So hopefully that kind of thought process or that questioning that you can do will help you as you're starting to create your own classes and decide, all right, is this thing its own class? Is it an instance variable? Etc. And here's just breaking down again the example of the canine and that intermediary superclass subclass. So canine is a superclass to wolf and it is a subclass to animal. Okay. You can imagine what that will look like, and you'll be actually coding coding some of these up as you work through Lab 3. So in Lab 3, your first job is to take all of these fruits and create an inheritance tree. And so you can do that in a text form if you have, fruit at the top, and then think about what might be next. Maybe it's apple, and then underneath that you have some of the different apples. Same thing with citrus. That might be kind of an intermediary superclass subclass. So your job to categorize all of those. If you aren't familiar with some of the fruits, give it a quick Google search and that should help you find the answer. And then you get to do some coding here as well. It's not just diagramming these out, and you can diagram them if you like to use flowcharting software. You're welcome to do that, or you can simply do it represented in a text document. But what I want you to do is then choose 3 classes that have this type of relationship where you've got a superclass subclass, and a subclass, and then write the code for those. So you'll create one method in each one. All that method has to do is just display the class name. So this is just to kind of get you used to designing the classes and then actually implementing them in code. Create a test drive and then actually run the test drive as well to call the method on each one. Okay, so that should be pretty straightforward. That is a short talk on inheritance trees. If you have any questions, please reach out on Slack. We'll see you next time.